Okay, today we're going to be dividing fractions, and we will be dividing mixed numbers as well. The one vocabulary word we're going to need today is the word reciprocal. Reciprocals are two numbers whose product is 1. For example, 9 and 1/9 are reciprocals because the product of 9 and 1/9 is 1. 7/8 and 8/7 are reciprocals because the product of 7/8 and 8/7 is 1. How do we find a reciprocal of a number? We write the number as a fraction and put it over 1, and we flip it. Alright? 7/8 is already written as a fraction, so I flip 7/8. 7/8 becomes 8/7, and the product of 7/8 and 8/7 is 1. So if we look at our first couple of examples where we're asked to find the reciprocal of each, we simply want to, if the number is written as a fraction, we simply flip it. So 3/4, the reciprocal would be 4/3. I just take 3/4 and I write it as 4 in the numerator, 3 in the denominator. Right? 7 is a whole number. So first I have to write it as a fraction, and then I flip it. So the reciprocal of 7, which is a fraction, is 7/1. The reciprocal would be 1/7. 8/3 is already written as a fraction. So if I want to find the reciprocal of 8/3, I just flip it, and 8/3 becomes 3/8. Alright, we haven't talked about a mixed number yet, so let's do a couple of examples of mixed numbers. So example D, we'll call it. And example D, if I have the mixed number, let's say 3 2/3, and I want to know what the reciprocal of 3 2/3 is. First I have to write it as a fraction. So 3 times 3 is 9, plus 2 is 11. So 11/3 is the fractional form of 3 2/3. Then I would take the improper fraction, flip it, and the reciprocal would be 3/11. Alright? So if I have a mixed number, I have to first write it as an improper fraction, and then I would flip it to find the reciprocal. If I have a whole number and I want to find the reciprocal of a whole number, first I write it as a fraction by putting it over 1, and then we flip it. If I already have a number written as a fraction and I want to find the reciprocal, I simply flip that fraction. Okay. Our next slide gets into, well, what does it mean to divide fractions? Alright, here is a rectangle, and first I want to try to model the division problem of 1/2 divided by 1/8. And when we model fraction division, I like to ask myself the following question: how many 1/8 are there in 1/2? Right? That's really the question that we want to ask. How many 1/8 are there in 1/2? Well, if I take a look at my model and I start with 1/2, right? 1/2 is going to look like this, right? Here's 1/2, right? And I'll shade this in, right? There's 1/2. So we have 1/2, right? And that's 1/2. I want to know, well, how many 1/8 are there in 1/2? Well, I'm going to change color so that it stands out a bit. All right, and then I'm going to split my same rectangle into 8 equivalent pieces. That's 4. All right. Right, that same rectangle I divide into eighths, right? Each of these is an eighth. All right, 1/8, 1/8, 1/8, 1/8. How many 1/8 are there in my 1/2? And the question to that would be 4, or the answer to that would be 4. Now, we can't make models for every single division problem. It just wouldn't be, efficient. So we want to come up with a quick way to get to that answer of 4. And the quick way is to use the algorithm, or the process that works over and over again. So I start with 1/2, and then I multiply by the reciprocal of the second fraction. When I multiply by the reciprocal, that means then that I have to change the division sign to a multiplication sign. I have to take the fraction 1/8 and use its reciprocal, which would be 8/1. Now I multiply numerator times numerator, denominator times denominator. Before I do that, though, I always look to see if I could simplify before I multiply, right? And I can divide out 8 and 2, That becomes 1 and 4. And now I'm able to multiply numerator times numerator, denominator times denominator, and 4 over 1 is equal to 4. Right? So there's a quick model that demonstrates, that question. How many 1/8 are there in 1/2? And there are 4 1/8 in 1/2. Okay? Let's look at our second example. We have 5/10, and I want to divide by 5/6. I want to know how many 5/6 are there in 5/10. All right, so I want to use the algorithm where we multiply by the reciprocal. So this becomes 5 over 10 times the reciprocal of 5/6 is 6/5. We divide out where we can, and we can divide out here and here by dividing by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. And I can divide out by 5 here. 5 divided by 5 is 1. 5 divided by 5 is 1. Now I can multiply numerator times numerator, denominator times denominator, and we wind up with 3/5. How many 5/6 are there in 5/10? Right, there would be 3/5. Okay, I have 7 cups of bird seed. I need 2/3 cups of seed each week. How long will your bird seed last? Well, if I start off with 7 cups and I'm using 2/3 each time I feed or each week, I'm asking how many 2/3 are there in 7 cups, right? How many 2/3 cups are there in 7 cups? So that's 7 divided by 2/3. When we divide fractions, I first have to write everything as a fraction. So that's going to be 7 over 1 times the reciprocal, right? I multiply by the reciprocal. It's going to be 3 over 2. Now, I look to see if I can divide out anywhere. Can't divide out here. Can't divide out here because the only common factor of 7 and 2 is 1. The only common factor of 3 and 1 is 1. So I can't divide out. So I multiply numerator times numerator. 7 times 3 is 21. Denominator times denominator. 1 times 2 is 2. If I want to write that as a mixed number, I would divide. 2 goes into 21 10 times with 1 left over. So I wind up with 10 and a half. All right. Let's try these examples down here. All right. We'll try example 2A. So if I try 2A, we have 9/16. I want to divide that by 3/4. When we divide fractions, I'm going to multiply by the reciprocal. So this becomes 9/16 times 4 over 3. I look to see where I can divide out, and I can divide out 4 and 16 by 4. So that becomes 1. That becomes 4. I can divide out 3 and 9 by 3. That becomes 1. That becomes 3. I multiply numerator times numerator, denominator times denominator. 3/4 is a fraction in simplest form. Let's try 2B, or not to be. That is 4/5 divided by 1/3. I want to multiply by the reciprocal, so this becomes 4/5 times 3 over 1. And be careful. Right, I often see students make the mistake of changing that first fraction. We never change that first fraction. That first fraction stays the same. Right, we don't use the reciprocal of the first fraction. We only use the reciprocal of that second fraction. I look to see if I can divide out, and I can't. So I multiply numerator times numerator. 4 times 3 is 12. Denominator times denominator. 5 times 1 is 5. I want to write that as a mixed number. So I divide. 5 goes into 12. 2 times with 2 left over out of the 5, so we wind up with 2 and 2/5 there. All right. Now if I look at problem 3 says your art teacher cuts 5 6-yards of fabric into 5 equal pieces. How long is each piece? Well, we start with 5/6 and we want to divide that by 5 equal pieces. When I divide fractions, and if I divide a fraction by a whole number, I have to first write that whole number as a fraction. So this becomes 5 over 6 divided by 5 over 1. Now that I've written 5 as a fraction, I can now multiply by its reciprocal. So this becomes 5 over 6 times 1 over 5. I look to see if I can divide out, and I can. I can divide out the 5's. 5 divided by 5 is 1. 5 divided by 5 is 1. Now I multiply numerator times numerator, denominator times denominator, and I get 1/6 there. Okay. Sometimes it's good to estimate a quotient, and if we're estimating quotients, we just want to, round each one of these numbers to the nearest whole number, if possible, if they divide evenly, and if not, we can sometimes use compatible numbers as well. So if I take a look at this first example, I have 59.5. A homeowner wants to cover a wall 59.5 inches wide with wood panels. Each wood panel is 4 3/8 inches wide. Estimate the number of panels needed to cover the wall. So we have about 60 inches of wood paneling, about 60 inches, and each panel is about 4 inches wide, right? Because 4 3/8 to the nearest whole number is going to be about 4. 60 divided by 4, that's going to be about, right? That's going to be 15. So it would be approximately 15 panels we would need, approximately. Okay, let's try each one of these. If we use estimates, we would try nearest whole number. That would be 7. Divided by the nearest whole number here would be 1. 7 divided by 1 would be 7. 9/16 is closer to 9/16 is more than half of 16, so to the nearest whole number that would be 15 divided by, well, 8/19 is closer to 3 than it is to 4, so that would be 3. 15 divided by 3 would be 5. Right, so if we just go to the nearest whole number for an estimate, that should be efficient enough way to do the problem. Okay, let's try some more examples. A baker has 2 1/4 cups of blueberries to make 3 batches of muffins. How many cups of blueberries should the baker put into each batch? Okay, well, we have a total of 2 1/4 cups, but we have to split that among the 3 batches. So that would be 2 1/4 divided by 3. I want to write each of those as fractions first. So 4 times 2 is 8 plus 1 is 9. So that's going to be 9 over 4 divided by 3 over 1. Once we have everything written as a fraction, we would multiply by the reciprocal. So this becomes 9 over 4 times 1 over 3. I look to see if I can divide out, and I can with the 9 and the 3. That becomes 1, that becomes 3. Now I can multiply numerator times numerator, denominator times denominator, right? And I get 3/4. How many cups of blueberries should the baker put into each batch? That should be 3/4, right? And our label there would be cups. Second example, the baker has 3 3/4 cups of walnuts to make 3 batches of muffins. How many cups of walnuts should go into each batch? Well, that would be your 3 3/4 divided by 3, and the same process would apply. Write everything as a fraction first. 4 times 3 is 12, plus 3 is 15, so we get 15 over 4 divided by 3 over 1. Once we have everything written as a fraction, we multiply by the reciprocal, so this becomes 15 over 4 times 1 over 3. I divide out if I can, and I can divide out 3 and 15. That becomes 1 and 5. And then we multiply numerator times numerator, denominator times denominator. Right, and I get 5/4 or 1 and 1/4. Okay, either one of those answers are going to work there. Okay, we continue. Right, we want to try maybe these on your own. Right, and then right, we'll go through them. Okay, but I'll start. First example, we want to write everything as a fraction first. 2 times 10 is 20 plus 1. That's 21 over 2 divided by 4 times 1 is 4 and 3 is 7 over 4. Once we write everything as a fraction, we multiply by the reciprocal. So the first fraction stays the same, 21 over 2. It's going to be times the reciprocal of 7/4 is 4/7. We divide out where we can. I can divide out 21 and 7. That becomes 1 and 3. Could divide out 2 and 4. That becomes 1 and 2. We multiply numerator times numerator, denominator times denominator, right? And we wind up with, I wind up with 6 over 1, or 6, as my answer. Okay. Write everything as a fraction first with our next example. So 7, we'd have to write a 7 over 1 divided by 6 times 1 is 6 plus 1 is 7 over 6. Then we multiply by the reciprocal. First fraction stays the same. The division becomes multiplication, and that becomes 6/7. Divide out the 7s. That becomes 1. That becomes 1. 1 times 6 is 6. 1 times 1 is 1. We have 6 and 5/6 divided by 3 1/3. Write everything as a fraction first. 6 times 6 is 36. 36 and 5, we get 41 over 6. Divided by 3 times 3 is 9 plus 1 is 10. It's 10 over 3. Multiplied by the reciprocal, 41 over 6 times the reciprocal of 10 over 3 would be 3/10. I look to see if I can divide out. I can divide out 3 and 6. That becomes 2. That becomes 1. I multiply numerator times numerator. That's 41. Denominator times denominator. 2 times 10 is 20. As a mixed number, 20 goes into 41. 2 times with 1/20 left over. So 2 and 1/20 would be correct. A few examples we can try here. I want to write everything as a fraction first. So in example 1, 1 and 3/7, we would write as 7 times 1 is 7 plus 3 is 10. So it becomes 10 over 7. The multiplication sign, I'm going to multiply by the reciprocal. The reciprocal of 2/3 would become 3/2. I divide out where I can, 10 and 2. That becomes 1 and 5. I multiply numerator times numerator. 5 times 3 is 15. Denominator times denominator. 1 times 7 is 7. 15 over 7 becomes 2 and 1/7. Okay, problem number 2. As a fraction, 6 times 2 is 12 plus 1 is 13. 13 over 6 times 4/3. I divide out 6 and 4. Divide by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. I can't divide out 13 and 3. So I multiply numerator times numerator. 13 times 2 is 26. Denominator times denominator. 3 times 3 is 9. Okay. 9 goes into 26 how many times? 9 times 2 is 18. And that's going to give me 8/9. So 2 and 8/9 for problem 2. Problem 3. Write everything as a fraction first. So 4 times 8 is 32 plus 1 is 33. So that's 33 over 4 divided by 2 times 1 is 2 plus 1 is 3. That's 3 over 2. Then we multiply by the reciprocal. That's going to be 33 over 4 times the reciprocal of 3/2 would be 2/3. We divide out. I can divide out everywhere here. Divide out by 3 here. That becomes 1. That becomes 11. Divide out by 2 here. That becomes 1. That becomes 2. I multiply numerator times numerator. 11 times 1 is 11. Denominator times denominator. 2 times 1 is 2. And 11 over 2 becomes 10 and a half. Right. In our last example here, we write everything as a fraction first. 5 times 6 is 30 plus 4 is 34 over 5 divided by 8 times 2 is 16 plus 1 is 17 over 8. and then we multiply by the reciprocal. So 34 over 5 times 8 over 17. Now this one's a little tricky to divide out because not everyone's going to see that 34 is a multiple of 17. So you can actually divide out by 17 here. 17 divided by 17 is 1. 34 divided by 17 is 2. Multiply numerator times numerator. 2 times 8 is 16. Denominator times denominator. 5 times 1 is 5. As a mixed number, 5 goes into 16 3 times with 1 left over. So 3 1/5 would be our answer there. Okay? Alright, I think this is our last page where we want to put all of the stuff we've been working on together. The addition, the subtraction, the multiplication and division of fraction and mixed numbers. So these would be multi-step problems, and we also have to use the order of operations as well. So there's a lot involved here. So let's take a look at our first example. We have to do this division before I can do subtraction, right? Because order of operations says we have to do division first. So in order to do the division, we have to write everything as a fraction first. So 4 times 5 is 20, plus 1 is 21 over 4, divided by 8 times 1 is 8, plus 1 is 9 over 8. And then we still have to subtract the 2/3. Next step, we multiply by the reciprocal. So the 21 over 4 stays the same. I multiply by the reciprocal of 9/8, which would be 8/9. Still have to subtract to 2/3. I divide out 21 and 9 by 3, so that becomes 3, that becomes 7. I divide out 4 and 8 by 4, that becomes 1, that becomes 2. I multiply numerator times numerator. 7 times 2 is 14. Denominator times denominator. 1 times 3 is 3. But we still have to subtract the 2/3. Well, I have 14/3. Take away 2/3. I can subtract the numerators because the denominators are already the same. So 14 minus 2 is 12. We have 12/3. And 12/3 is the same as 4. Because 3 goes into 12 4 times. Okay? Interesting problem here. It says 1 serving of tortilla soup is 1 2/3 cups. A restaurant cook makes 50 cups of soup. Is there enough to serve 35 people? Okay? Well, he makes 50 cups of soup. And we want to know, well, if each serving is 1 2/3, will that be enough to serve 35 people? So I need to know how many 1 2/3 cup servings are there in 50 cups. So that's going to be 50 divided by 1, oops, let's rewrite that, 50 divided by 1 2/3. Step number 1, write everything as a fraction. So that's going to be 50 over 1 divided by 3 times 1 is 3 and 2 is 5. That's 5 over 3. Next step, we multiply by the reciprocal. So it's going to be 50 over 1 times 3 over 5. I divide out if I can, and I can divide out 50 and 5 by 5, so that becomes 1, that becomes 10. I multiply numerator times numerator, denominator times denominator, right? And that gives me 30. Well, that's 30 servings, right? And because 30, right, is less than 35, the answer is no, right? We can't serve 35 people. All right? So let's take a look at these examples here. Okay, you guys can try them on your own if you want. Right, you can stop the video, but I'm going to go ahead and do them at this time, and that'll finish up our lesson today. So I start with number 5. Right. First, I want to write everything as a fraction. So 2 times 1 is 2 plus 1 is 3. So that's going to be 3 over 2 divided by 1 over 6 minus 7/8. I have to do the division before I do the subtraction. So this becomes 3 over 2 times 6 over 1 because we have to multiply by the reciprocal. Still have to subtract the 7/8. I look to see if I can divide out, and I can divide out 2 and 6. That becomes 1 and 3. I multiply numerator times numerator, denominator times denominator. 3 times 3 is 9, 1 times 1 is 1, and then I still have to subtract 7/8. Well, at this step here, what is 9 take away 7/8? Well, 9 take away 7/8 is going to be 8 and 1/8. Alright, but in my head, this is what I'm doing. I'm rewriting 9 as 8 and 8/8, right? Because 8 over 8 is 1, right? And 1 plus 8 is 9. So I'm rewriting the 9 over 1 as 8 and 8/8. I'm taking away 7/8. I can subtract 7/8 from 8/8. That's where I get the 8 and 1/8 from. For problem number 5. Alright, do number 6 over here. Use a different color. Problem 6. Write everything as a fraction. First, 3 times 3 is 9, plus 1 is 10, so that's going to be 10 over 3, divided by 5/6, plus 8/9. We multiply by the reciprocal when we divide fractions, so my next step, 10 over 3 times 6/5. But then I still have to add 8/9. I divide out if I can, and I can divide out everywhere here. Divide out by 5s, that becomes 1 and 2. Divide out by 3s, that becomes 1, and 3 goes into 6 2 times. Multiply numerator times numerator, denominator times denominator. I get 4 over 1 plus 8/9. So what is 4 plus 8/9? Well, that is simply 4 and 8/9. Alright. Let's try question 7. Right down here. Let's say he's black here. Question 7. I'll recopy it down here so I can see a little better. This is 2/5 plus 2 and 4/5 divided by 1 and 3/4. Right, now these are the types of problems that students make mistakes on all the time because they get so involved with the fraction stuff they forget their order of operations. But we have to do this division first before we can ever do that addition. So I'm going to recopy to 2/5 plus, and now I'm going to rewrite these as fractions. 5 times 2 is 10, plus 4 is 14, so that's 14 over 5, divided by 4 times 1 is 4, plus 3 is 7. Right, so my first step, write everything as a fraction. Next, I want to multiply by the reciprocal. So I recopy the 2/5 and the plus sign, right, because I have to save that addition from my last step. 14 over 5 times 4 over 7. I can divide out, right, because the reciprocal of 7/4 is 4/7. I can divide out 14 and 7 by 7. So that becomes 1, that becomes 2. Then I multiply. 2 times 4 is 8. 5 times 1 is 5. Right, so that's going to give me 2/5 plus 8/5. And 2/5 plus 8/5, that is going to give me 10/5, which is the same as 2 for problem 7. Alright, and our last problem, I'll write it down here. Problem number 8. Problem 8 is 2/3 minus 1 and 4/7 divided by 4 and 5/7. And once again, we have to do the division before I can do that subtraction according to the order of operations. So this becomes 2/3 minus 7 times 1 is 7, plus 4 is 11, that's over 7, divided by 7 times 4 is 28, 28 and 5 is 33, that's over 7. Then I want to change that division to multiplication, and so we will multiply by the reciprocal. Recopy the 2/3 minus 11 over 7. Division becomes multiplication. 33 over 7 becomes 7 over 33. I divide out where I can. I can divide out the 7s by 7. They become 1s. Divide out the 11 by 11. That becomes 1. 33 divided by 11 is going to be 3. Numerator times numerator. Denominator times denominator. Recopy the 2/3 minus. 1 times 1 is 1. 1 times 3 is 3. So we have 2/3 minus 1/3 which is going to be 1/3. All right, that's the end of the lesson. I hope that is helpful, and see you again later.